I'd like to look at, one of the things that people are concerned about is, how do I get my infrastructure to scale? Let's look at why slow happens. There are really 4 reasons. The server can have a problem, the pipe can have a problem, connection between you and the machine. You can have too many requests, that was the denial of service attack scenario, but your clients can give you your own denial of service attack. We've had times when we've had a promotion that was incredibly successful that actually slowed everything down to a crawl, and tell me that's not a nightmare. You've slowed yourself down at the time when you desperately didn't want to be. Or you can just have a small number of people using it, but you're asking them to do something hard. There can be just complex math in the scenario. So some tips around this. Firstly, define what big is for you. So for different clients, big, as in a big number of users, it can be very different. You want to have that conversation with your developer. How likely is a surge? Business to business platforms typically get less surges than business to consumer. So business to consumer platforms, when something gets popular, it gets really popular, and every business changes on this, but think about how likely a surge in traffic is. We've got one client, and I think it's either Thursday or Friday at 4 p.m, they get 80% of their business inside an hour, just the nature of their business, and so that's the surge that they have to manage for every week. We can solve, so 4 techniques that we can use. We can get more hosting capacity. We can have what's called vertical scaling, just make it a bigger server. I've seen scenarios where that's been helpful. A really common approach now is to get more servers. So Google does not run one big server. Google runs thousands and thousands of actually pretty basic servers, and the problems, the requests are routed between them. This is going to be the most techie bit of today, and we've used cartoons, so hopefully it'll go down. But I think it's important to know what are the types of ways that you can host your platform, because once you understand this, this is the bit that when you know it, you can have some really good conversations with your developers. So let me do this as a history lesson. Starting off, we just had dedicated servers. It was a box. You owned it and you had it, and it was your box. And on that server, we would put your operating system, Windows, Linux, whatever it might be, and we'd put your databases and we'd put them all on your server. And there are plenty of people for whom this is exactly the right infrastructure still today. There is a problem, however, and that is these things were expensive. So what we did is we created shared hosting. Shared hosting is we put lots of people together, and we get one big beefy box and we put 100 or 500 people on the one box. The only problem is when somebody does something evil, it can affect everybody else. So they can, if it goes evil, they can, the time can, the process that you're running can affect everybody else on the server. So we came up with a third solution. It's called a virtual private server. A virtual private server, effectively, it's like we take one big server, and under the hood there's a couple of ways we can do this, and so I acknowledge the technical people in the room, but we can think of it as one big server cut up into 6, 8, 9 pieces, and each of those acts like its own server. It has its own operating system, and if someone goes rogue, nobody else cares. It's like sharing the cost of a big one, but really carving stuff up. Then we have a fourth option. The most recent move is this thing called cloud services. Now, cloud services I could talk about that for 3 days. There's lots of stuff that happens in here. But essentially by magic, by a whole bunch of machines working together really cleverly, we can have what look like our own servers, plus we can buy these other services. We can buy a database. So we might buy a little mini server, and we can have control over it. We can actually go into it and, as a dial, just say, I'll have some more power, please, and just crank it up. And that server grows, or we get more of them instantly. In fact, we can tell the software to do it on our behalf. We can buy a database, and we can buy other magical services like queues that I'll introduce in just a moment. Now, this is the slide I ummed and ahed about putting up, because everything on this slide is mostly true. As in, I can give you a counter argument to where I can give you a case where each of these is not true. But we're talking about the service offerings of companies all around the world, and I wanted to give you some general ideas. But please don't ring me back and say, I found a hosting company that'll do this for a quarter of the price. Great, I did too, but this is what our general experience is. Shared hosting, it's going to be pretty cheap. It's not made to scale. You're going to get capped pretty quickly. Their disaster recovery is generally slow. Like if it goes over, it typically takes a while to recover. You don't have to pay extra for management. They don't have much in the way of extra, not often a lot of extra services. And we like WP Engine and Anchor at the moment for that service. Good in the cheap end. Virtual private servers, you can see that the cost goes up, but they are built to scale. You can often scale a virtual private server really quickly. You can ring up the hosting provider and say, we're busy, can you scale it up for me? And depending on your provider, they'll do that instantly, or they might take a few days. Disaster recovery is slow. You still have to rebuild a lot of stuff when they go down. They take a while to recover. And they will charge you, it's like having your own server, so they'll charge you a lot for management. If I go over to, actually I'll jump over to dedicated servers. Dedicated servers are kind of like a virtual private server, just beefed up. The interesting one is this one in the middle where it's cloud services. So cloud services typically start at low cost. They can very quickly get a lot more expensive. I know people who spend, we did some consulting for some people who are spending $400,000 a year in cloud, so I don't think it's always cheap, but you start out at a low cost. You can scale them up nicely. You can often scale them instantly, and your disaster recovery can be really fast. You actually recover the whole instance, not just, you don't have to put the code back in the database, they come back really quickly. Management can cost, it depends whether you're paying extra for management, and you get lots of extra services. There is lots of cool things coming out, well, cool that we think are cool. Cool is a variable word. There are lots of really useful little services coming out in the cloud environment that can do specific jobs, and I'm going to give you an example of one of those that can get out of a particular problem that we didn't have going back a while ago. So, appropriate hosting certainly helps with scale. This one I just put in for fun. This actually, a little while ago, the best hardware that you could buy, value for money, was a PlayStation. And you could put whatever operating system you liked on the PlayStations. So the US Department of Defense bought a whole bunch of them. They stuck them all together and they built a supercomputer out of PlayStations. And supercomputers are actually just lots of computers strung together and controlled in an effective way. I just think it's cool that there's a place where you can go and, the US Department of Defense is analysing data from around the world to keep America safe on a whole bunch of PlayStations. I reckon that's pretty cool. Caching, so this is another technique we can use to scale. Caching is the act of storing something for later use to make us faster. So pre-calculation, if you've got a whole bunch of really complex math, if that's done on the fly each time, that can be really slow and expensive. Sometimes you can pre-calculate that. I'm going to give you a bit of lingo. I'm going to teach you with pictures what a content distribution network is. You will be much more geekier at the end of this, I promise. We've got a server, and it's happy. It's having requests coming from all around the world, and that's fine. Different devices. Now it's less happy because it's getting hit from lots of stuff. It's beyond its capacity to handle. So what we can do is we can take the images, because when you serve up a web page, you've got to serve up pages and images. We can take the videos, a lot of the stuff that stresses these sites out, and we can put them on these other friendly servers around the world. And we can have one in every country of the world. And what happens is when people come to our website, they think they're coming to our website, but they're actually picking up most of what they want from an intermediary server along the way. And so the number of requests actually getting back to the mothership is dramatically reduced. And this can make sites run a lot faster, particularly sites, your Australian site might look good to you in Australia, and then you go on holidays and you realise in America it's actually slow. And it's really bad in the UK. If we can distribute your content around the world, we can make your site appear to be a lot faster and to run a lot faster. Now the beauty of this is, these services used to be really expensive. The cost of these has come down significantly. We've got people running CDN, this is called Content Distribution Network, CDNs for, so there's actually some good free offerings at $20 to $100 a month. It's not expensive to get good CDN offerings. Queuing, we can put requests into a queue and we can get to them in turn. This is a great trick when it works. So imagine I've got a server, and this is the normal load that comes through to that server. And then, I don't like it, I'm getting too much. What I can do is I can put a queue in front of it, and I can slow down my request so that my server is happy. Now let me give you an example where that's useful. We built a platform in the SMS space. These people send SMSs on behalf of businesses. So other websites connect to them, give them a bunch of requests that they go and send out SMSs. It just so happens, Friday afternoons, a lot of their customers, and I mean customers who send them big requests, hundreds of thousands of messages, come flooding in, and they've got to be able to handle them. Now for that 10 minutes, and it's probably 10 minutes a month when they often get them all crossing over, normal infrastructure would fall over. But we can use a queue to sit in front of it, absorb all the requests, and the worst case that happens is a message might take 10 minutes to get out. But the queue, this queuing infrastructure, I can buy it from cloud services for very cost effectively. I can push all my stuff into it and I can just get to it when I get a chance. Now that, essentially queuing works when you're dealing with other services. It doesn't work so well with humans because if I've got a web page and I want to wait 10 minutes for a response, it's not so much fun. But when they work, they're great. Improving algorithms. Levi regularly says this to me, which is premature optimization is the root of all evil. Now, the love of money is the root of all evil, but premature optimization is the root of all evil. Let me give an example of somebody in the room. And these are rough numbers, but they have a few pages on their site that they require this much processing power to run. Not much. Then they've got a data entry page which requires heaps of processing power to run, another report that requires heaps, and so the natural inclination is, well, do we go and give them a bigger, beefier server to do all of this math? What we actually did was did some optimization work on just those 2 pages. We left these ones completely alone, and we were able to bring the actual amount of processing required significantly down. Now, you might be asking the question, well, why didn't you just do that up front? Like, why did you have to wait for all of this? And there are some problems with optimization. A, it takes a while. As in that bit of work, there was days, in some cases weeks worth of work to get that to happen. But B, it's also, these pages are now internally more complex. They actually will take more time to run. So typically we do optimization problems. We don't try and pre-optimize too much, but there are lots of problems. So for example, let me give you one of our best examples. We built an Australian directory that has every business in Australia within it, and we created a search algorithm to search across that entire database for using geographic identifiers. When we first built it, it took 2 minutes to run. It gave you the correct answer, but it took 2 minutes to run. And there was the competitor in that space had a farm of servers. And the thought was we were going to buy a whole bunch of hardware and there's a whole bunch of cost. And what we did is we got a really good programmer and we put him in a dark room for 2 weeks and we fed him a lot of pizza. And in 2 weeks, he got this algorithm, which we'd tried a bit already, to run in under 2 seconds. Now, it's a pain to keep. When we want to change it, there's a lot of work. But we changed the internal structures of queries. We did a whole bunch of dark arts and black magic. But can you imagine, that happened, I think, 6 years ago, 7 years ago. There's been tens of thousands of dollars of accumulated costs that have been saved because we were able to optimize an algorithm. And the things that engineers actually know is that people will often rush to buy better hardware when they'd be better off to actually make an investment in a better algorithm. So what do? We buy typically a bit more capacity than we want, and we monitor it and we resolve issues as we go through. That's the end of this session. We're going to take a 2 or 3 minute break and we'll do the second piece. Grab a cup of coffee. That was the heaviest one of the lot, I promise. That was the learning one. The rest are a lot easier.